Hey there, welcome back. All right, in this module, we're going to learn about the dreaded waste of transportation. Specifically, by the end of this module, you'll know exactly what the waste of transportation is, what causes it, what it costs us, and some tools and techniques we can use to eliminate or at least greatly reduce it. Okay, well, following our traditions, let's start off by learning what we mean when we refer to the waste of transportation. Well, formally defined, the waste of transportation is the movement of materials that adds no value to the product. Another way of saying it is that transportation is the movement of material using carts, trucks, forklifts, or simply your arms and legs. And it should be also said that while moving product in a conveyor is not as bad as moving material from one disconnected process to another, it's still conveyance, a type of transportation waste, since conveyors are inflexible and require space and energy. Now, some examples of transportation waste are moving finished goods to storage, moving work in process to the next step, moving between functional areas, moving parts to the line, and moving items to quality assurance. So that's what this waste is. Now, let's turn our focus to what causes it. The first thing many companies battle are outdated plant layouts that are not optimized to minimize transportation. Another cause is the fact that many so-called mass producers still produce large batch sizes that require forklifts to move it about the plant. Next, huge warehouses with massive racks of inventory as far as the eye can see are major causes of this waste. Of course, in some industries it's difficult to not hold inventory in large racks, but our goal as lean producers must be to hold as little inventory as possible. Finally, the need to transfer material from one work area to the next, and in some cases stage this material, also contributes to the waste of transportation. Alright, well now most of us are used to seeing forklifts and pallet jacks and other material handling equipment zooming about the facility. But one thing many of us don't think about as much as we probably should is what all this transportation costs our companies. So let's explore this now. Among many other things, the waste of transportation often increases the lead time of our processes due to the transportation delays. There's also labor and equipment costs for moving material. There are also people needed to create things like transfer orders, and then there's the cost of forklifts and pallet jacks and pallets, and of course the fuel needed to operate the forklifts. So it's safe to say that the cost of transportation to most organizations is extremely high. So with this said, let's discuss some tools and techniques we can use to battle transportation waste. Now, the first thing we can do is rearrange our factories and even our office areas into a cellular layout whereby material flows in a smooth and consistent manner. And taking this material flow even further, it would be optimal if we operated within our work areas using the one-piece flow concept. But before we look at one-piece flow, let's review the two other types of flow we often see companies use. The first layout is batch and queue, whereby each workstation builds in large batches and pushes its inventory to the next station. Well, this pushing requires transportation since these batches are often more than a person can safely move without assistance. The next type of flow is what we call fake flow. Here, transportation is reduced when compared to batch and queue, but since things are not balanced, since we see the operator on the far left has 4 pieces, the waste of transportation will still be evident. Now the final and optimal type of setup is one-piece flow, sometimes called one-piece pull, since no work is started unless a downstream customer asks for it. Also, all work is balanced at takt time, so the maximum amount of inventory that would ever need to be handled is one piece, thus radically reducing the amount of transportation required. Another excellent technique used to minimize transportation is to have clear material replenishment routines outlined. And while there's still the waste of transportation in these systems, the waste is greatly minimized by the standard way of picking jobs and the excellent visual management that accompanies these systems. Now, this next concept might win the award for the most unique name of all time, the water spider system. Now, we'll dive into setting up a water spider system in a later course that focuses on Kanban, but allow me to offer a brief explanation of what this system is now. Well, this system gets its name from the water spider, which is a beetle that moves about inside the water, not on the surface of the water like some think. Now, the water spider position is often confused with a simple material handler or an entry-level go-fetch person. But this is actually completely wrong. The water spider needs to be thoroughly familiar with the materials, tools, and methods of the process they're supporting. Now, many experienced Japanese lean experts often explain that the water spider role is a rite of passage to becoming a supervisor. Now, the water spider is an honored and critical role at making continuous flow and smooth lean systems a reality. Now, John Miller, one of the Gemba Canopy's founders, actually wrote an excellent article explaining what this system is all about. And we'll link to this article in the PDF download document for this module. So you'll definitely want to check that out. And now, for my first official warning. If you'd like to see what one of these water spiders looks like, keep your eyes open, as I'll show you one here in a second. But let me warn you, these little critters look a bit like cockroaches, so if you're squeamish, you might want to look away. Okay, drum roll please. Allow me to introduce you to my pal, the water spider. Cute little guy, huh? Alright, finally, the last two techniques that can greatly reduce the amount of transportation required is point of view storage and direct line delivery, meaning all supplies needed to do your job are always available and the person doing the work never has to leave his or her own workstation to get their supplies. Now, as you see here, Isaac is forced to leave his workstation while walking across the plant, which is motion, in order to get his cart, pick up the shrink wrap, and then transport it back to his workstation. But in his new and improved situation that now uses point of view storage and direct line delivery, Isaac doesn't have to leave his workstation in order to get the supplies he needs to do his job, as we see here. And that's the waste of transportation. So in our next module, we're going to learn about the seventh and in fact the deadliest waste of all, overproduction. So we'll speak to you soon.